Hello, Math 2 students. The purpose of this video is for you to learn how to take an equation that's in standard form and change it to intercept form. That way you have the advantage of everything that standard form tells you and everything that intercept form tells you. And once we're able to have our standard form equation and also our intercept form equation at the same time, it's easier to find all of the key characteristics that we're looking for. So to start with, how do you change from standard form to intercept form? You change from standard form to intercept form by factoring. So before we go any further, here's 3 factoring problems to help you practice and remember what we did in chapter 2. In our first factoring review problem, we have a binomial, and we can think of that binomial as being in standard form. So if we find our x squared term and we look at the coefficient in front of it, our a value is -3. And then if we find our x term and we look at the coefficient in front of it, our b value is 12. And then there is no third term, so our c value is 0. Now, if we want to factor this, since our a value is negative, we know we're going to take out a negative number as our greatest common factor, even if it's only 1. But in this problem, I can see that the biggest number that goes into 3 and 12 evenly is 3. And both terms have an x, so they have a greatest common factor of x. So my greatest common factor on this problem is going to be -3x. So now when I take the -3x out, I'm going to have a number in the front of the parentheses, and I'm going to have 2 numbers inside the parentheses. That's going to be a binomial factor. My greatest common factor is going to go in the front, so that'll be 3x. Now I need to think to myself, 3x or -3x times something is -3x squared, and that's going to be +1x. And -3x times something is going to give me +12x. That will be -4. Now, this cannot be factored any further. That is a binomial factor. There's no x squared in there. And my greatest common factor is -3x. So that is the factored version of this standard form binomial. In this problem, we have another binomial, and we can think of it as being in standard form. So if I find my x squared term and I look at the coefficient in front of it, my a value is 2. When I look for the x term, there is no x term. So my b value is 0. And then I have a term in the back that's not connected to an x, so that's called a constant term. My c value is -50. Now, when I look at this binomial, I can see that my a value is not 1, so there might be a greatest common factor to look for. And when I think of 2 and 50, and I think of the biggest number that will go into both of them evenly, it will be a 2. So my greatest common factor on this problem is 2. So again, I'm going to have a number in the front of the parentheses and a binomial factor following that. My greatest common factor is 2, and it's going to go into the front. And then I think to myself, 2 times some number is 2x squared. And so it's not going to be a number, it's going to be a variable. 2 times x squared is 2x squared. And 2 times something is -50. So that's going to be -25. And so now I have my greatest common factor. I have a binomial here, but my binomial should be something that you recognize. This is a perfect square, and this is a perfect square. So this is a difference of 2 squares problem. And whenever you have a difference of 2 squares, you can factor it by making a sum and difference pattern. So my problem is going to look like this. I'll have 2, and then we're going to break up this difference of 2 squares into 2 binomial factors. And it's a difference of 2 squares, So we'll have a sum and difference pattern, x plus 5 and x minus 5. And if we want to check and make sure that we have this right, we can check it by foiling. So we have our firsts are x squared, our outers are negative 5x, our inners are positive 5x, and so the negative 5x and positive 5x are going to add up to 0. That's why we have a b value of 0. And finally, negative 5 and positive 5 is negative 25. So when I FOIL these binomials, I will get this binomial for the answer. So this is the factored version of this standard form polynomial. In our final factoring practice problem, we have a trinomial. So if I find my x squared term and I look at the coefficient in front of it, I find out that my a is 1. If I find my x term and I look at the coefficient in front of it, I find that my b value is negative 9. And if I look at the constant term in the back, I find out that my c value is 14. So remember, when your a value is 1 and you're dealing with a trinomial, you just need to find two numbers that multiply to c but can add or subtract to b. So we need two numbers that can multiply to 14 but add or subtract to 9. So our choices are 1 times 14 or 2 times 7. And we can see that if we have the right signs, the 2 and the 7 could possibly come together and form a negative 9. That won't work with the 1 and the 14. So I think that my factors are going to include a 2 and a 7. Now when we look at the signs, our c value is positive, which means our signs have to be the same. It's either positive 2 times positive 7 is positive 14, or negative 2 times negative 7 is positive 14. But when your c value is positive and your b value is negative, you know that both of your signs are going to be negative. So quickly I can check this by foiling again. X times x is x squared. My outers are negative 7 and my inners are negative 2, which is negative 9. And negative 2 times negative 7 is positive 14. So these binomial factors are the factored version of this trinomial. Now, after practicing those three problems, when you look at this problem in standard form, you probably recognize right away that our a value is 3, our b value is negative 6, and our c value is negative 45. Now, because our a value is 3, we need to double check and we need to see if there's a greatest common factor. What is the biggest number that can go into 3 and negative 6 and negative 45 evenly? Well, the biggest number that can go into 3, negative 6, and negative 45 is 3. So the greatest common factor on this problem is 3. So we'll start out and we're going to have a number in front of our trinomial and we're going to put our greatest common factor there. And then we have to think 3 times something is 3x squared. So that's going to be x squared. 3 times something is negative 6x. That'll be negative 2x. And 3 times something is negative 45. If you're not sure about this one, remember you can always just divide every term of the trinomial by the greatest common factor. So negative 45 divided by 3 is negative 15. So if this is our problem so far in standard form, we're making progress towards turning it into factored form. So it would now look like this. But you should also realize from your factoring practice that we can take this trinomial and now we have an a value of 1. So we just need to find two numbers that multiply to 15 but can possibly add or subtract to negative 2. So that's going to be 1 and 15 or 3 and 5. And so the only numbers that have a chance of adding or subtracting to negative 2 is our 3 and 5. So now my problem is going to become 3 times, there's my two binomial factors, there's x and x, and I'm going to use 3 and 5. Now, whenever your C value is negative, you know your signs are going to be different. And I know because my B value is negative that I want more negatives than I have positives. So I'm going to make the 5 negative and the 3 positive. Now I'm going to check by foiling x times x is x squared. I do the outers, and that's negative 5, and the inners is positive 3. So that'll make negative 2x. And then when I multiply the last, that'll be negative 15. So after factoring, I've just changed this function, which was in standard form, into this function, which is in intercept form. Now that we have both forms of the equation, now these equations will both make the same graph, but we have both forms of the equation, we can use both of them to identify these key characteristics. So I'm going to start out with the x-intercept. I know that if I take the intercept form equation and I say to myself, okay, I want y to equal 0, and I want to find all of the x values when y is 0. So we don't have a variable in front of our parentheses, so we don't have to worry about that. But I do know by the zero product property that x will be negative 3 or x will be positive 5. So my x-intercepts are negative 3 and 5. All right, now for my y-intercept. For my y-intercept, I should go back to standard form because whatever the c value is in standard form is the y-intercept. So my y-intercept is negative 45. Okay, now to find the vertex. We could use standard form or we could use intercept form to find the vertex. So we're going to try it both ways. So if I want to use standard form to find the vertex, the x-coordinate of the vertex and the axis of symmetry can both be found by using this formula right here. When I'm looking at intercept form, the axis of symmetry or the x-coordinate of the vertex can be found by using this formula right here. Now, since both of these equations will create the same graph, both of these are going to give us the same answer. So my b value is negative 6, so I have x equals negative 6 in the place of the b over 2 times a, and our a value is 3. So that's going to give me positive 6 over positive 6, which is 1. So my axis of symmetry is x equals 1, and the x-coordinate of my vertex is 1. If I go to intercept form, I take my two x-intercepts and I add them together and divide by 2. That's going to give me 2 over 2, which is 1. So as you can see, when you're looking for the vertex, you can find it in standard form by using one equation, or you can use intercept form and use a different equation to find the x-coordinate of your vertex. Now, no matter which equation you used, the next step is going to be the same. You're going to take your x-coordinate and put it back into your function. Here we would take our x-coordinate and put it back into the function. So that's going to look like this. I'm going to not write it in function form though. I'm going to go y equals 3 times empty bracket squared minus 6 times empty bracket minus 45. And I'm going to put a 1 here and a 1 here. So this is going to be y equals 3 times 1 minus 6 times 1 minus 45. So that'll be y equals 3 minus 6 minus 45. And so that will make negative 48. All right, now if I use intercept form, I'm going to go like this. Y equals 3 times empty bracket plus 3 times empty bracket minus 5. And I put my 1 in the empty bracket. So that will be 3 times 4 times negative 4. And 3 times 4 is 12 times negative 4 is negative 48. So using standard form, my vertex was 1 comma negative 48. And using intercept form, my vertex was 1 comma negative 48. All right, now for the domain and the range. Since my A value is positive, I know my parabola is going to open up. So I'm just going to make a crazy little sketch of this thing. So I have a parabola that opens up and its vertex is at 1, negative 48. So it's going to look something like this. But the important thing is, since my vertex is here, I can see that all of my y values will be above the vertex. So since it's above, my y values are going to be greater than or equal to that negative 48. So my domain is all real numbers. And my range is y is greater than or equal to negative 48. So that's how you change standard form to intercept form, and then you can use the different things that you can see at a glance in standard form and the different things that you can see at a glance in intercept form to help you find the key characteristics. We also learned that you can use this formula to find the vertex and then plug it back in to your original function, or you can use this formula to find the vertex and then plug that back into your original function. And because these two equations create the same graph, of course they have the same vertex.